Hi everyone, welcome to our channel Coroutine Lab. In today's competitive job market, if you've recently applied for an Android developer position, you've likely been asked to share a sample Android app for review. This helps the hiring team gauge your understanding of the latest technology trends in the industry. But don't worry, we're here to help you achieve this. With our comprehensive guidance and learning resources, you'll be able to build and showcase your Android app using the latest best practices, ensuring you stand out and succeed in your career journey. This course will be divided into 3 videos, where we will guide you step by step in creating a 2-pager Gmail clone application. We'll focus on using the latest Android guidelines and industry standards, ensuring that you not only build a functional app, but also learn modern development practices to enhance your skills. In the first part, we will learn about Retrofit, which is a network library to connect to our mock API, Hilt for dependency injection, Glide for loading images, Jetpack Compose for our UI, and Mock-K for doing our unit testing. Throughout the course, we'll apply the MVI architecture and structure the project using a multi-module. Do not worry if some of the concepts is not known to you. We will cover it as we make progress. In this part, we'll also focus on the basic setup, such as creating the modules and implementing the data and domain layers. In the next video, we'll move on to creating the UI and integrating it with the data and domain layers. Finally, in the last video, we'll cover unit testing. While testing is typically done alongside development, we'll keep it as a separate video for simplicity and clarity. But why are we doing the data and domain layer first and not the UI layer? Let's take an example of building a house. You don't start with painting the walls or installing furniture. You first lay a solid foundation and structure. The data and domain layers act like the foundation of your app. Second advantage is stability. Think of the data and domain layers as the plumbing and electrical work in a house. You need to make sure the pipes and wiring are correct before putting up walls. Third advantage is separation of concerns, which is one of the core principles in building software. Imagine trying to figure out how the electrical system works in a house that's already fully decorated and filled with furniture. Similarly, in software development, when concerns like data handling, business logic, and UI are tangled together, making changes or troubleshooting becomes a complex task. By using a multi-module structure, you keep each layer, data, domain, presentation, separate and focused on its own responsibility. Next advantage is flexibility. If you decide to repaint the house or change the furniture, which is equivalent to UI, it's easier if the structure and foundation are already solid. Last is testing. Focusing on the data and domain layers first allows you to unit test the core logic, ensuring that everything works properly before the UI layer is built on top of it. Before we start coding, let's see what all things we are going to need. First is the API. For this project, we will use a mock API website to create 2 endpoints, which are email list and email details. For UI, we will take the reference from the Figma design by Scarlett Rivera. Links for both will be available in the description below. Also, we will be building a multi-module app using Jetpack Compose, which will have majorly 3 module, data, domain, and presentation. We will also have some more modules which will be core UI and core, but that will be explained later in the video. This architecture pattern is also famously known as Uncle Bob Clean architecture pattern. The basic idea is we segregate our code in such a way that the domain holds the pure business logic and should not have any dependency on the external framework. Data module holds the info how and where the data is fetched from. It could be local or from remote. And finally, the presentation module, where we have Android-related stuff, which is basically our views and view model. The inward arrows represent the flow of dependencies or symbolize the direction of control. They indicate that inner layers should not depend on outer layers. Only outer layers depend on inner layers. The whole purpose of this architecture is to make your code flexible, maintainable, and testable, with the ability to swap frameworks without changing core logic. Here is the quick snapshot of what are some of the major libraries we will be using to create our project. You can also use the alternative library if you want. The Ktor, Coin, and Coil are very important libraries, especially if you're working in campy projects. We will create a video about that in the future. Now let's get started and do some coding. Open Android Studio and click on Create New Project. On the next window, select the empty activity template and click on Next. Let's keep the name of the project as Gmail Mock. Keep the rest of the configuration as it is and click on the Finish button. It will take a couple of minutes to do the Gradle sync. Meanwhile, let's create our API endpoints. Open mock API.io. Click on the Login button and sign in. I'll use Google for the sign up, but you can choose any method you prefer. Once you're signed in, you'll land on the main page. Since we don't have any projects yet, click on the plus button. I'll name my project email and set the API prefix as /API/v1. You can keep it blank if you like, then hit the Create button. Now that our email project is set up, let's create the two endpoints we discussed earlier. First, we'll add a resource for the email list. For this video, I've already created the JSON file, which I will return as a JSON response for the endpoints. Click on Data and paste the response. I'll also share a gist link to this sample response in the description, so feel free to tweak it as needed. Let me also quickly do the same thing for email details. Keep in mind that the free tier model returns data as an array, which might feel a bit odd for the Details API, but it works for now. Let's take a moment to understand the breakdown of an API endpoint. If you take a look at the API, it's generally divided into four major parts. First, we have the scheme, like HTTPS, then the server, which is the domain, followed by the path, the specific resource or action you're targeting. Finally, there are the optional query parameters that filter or modify the request. Together, these parts make up the URL for the endpoint. Okay, now that our project is synced, let's start creating our modules. There are various modularization techniques which are used across the industry, often influenced by the factors like complexity of the app, number of developers, or how teams are structured within organizations. I'll dive deeper into this in future videos. First, let's create our data module. Select Android library and name the module name data. We'll also create the domain, presentation, and core modules in a similar way. Let me quickly set those up. Apart from the points discussed earlier, modularization also speeds up build times. By splitting the project into smaller modules, only the changed modules need to be rebuilt, which significantly enhances the development process, and it allows you to clearly see and work on the specific section of the app you're dealing with. Let's define the packages for each module. In the data module, we'll create mapper, remote, and repository DTO packages. In the domain module, we'll create model, repository, and use case packages. In the presentation module, we'll organize by feature, creating email list and email details packages. Next, we will add the dependency for our different modules using version catalog. But first, what is meant by dependency? Dependencies frameworks or libraries that your app uses to perform specific tasks, like networking, image loading, or database management. Instead of writing all the code from scratch, you depend on these pre-built solutions to save time and effort. Version catalogs simplify managing dependencies across your Android projects. Instead of hard-coding versions in each module, you define them in a central location, making updates and maintenance a breeze. With version catalogs, you can declare versions for libraries, plugins, and even use aliases to reference them. Version catalog file is typically found inside the Gradle folder and is named as libs.version.toml. If it's not there, you can create it manually. This file has three sections: library, plugins, and version. Let's take a popular networking library like Retrofit as an example. To include the retrofit in our code, you could either hard-code the path inside your module build.gradle file or keep it in the version file. The path consists of three parts: group ID, artifact ID, and version. Here, group ID is the first part before colon. It typically represents the organization or developer. The artifact ID is the name retrofit after that, which is the name of the specific library or module you're using from the group. And finally, we have the version, which is the last stable release of the dependency. For example, you would put 2.11.0 under the versions block and assign it a reference variable. Then, you add the remaining part under the library section. Sometimes you'll see the keyword module, which combines the group ID and artifact ID. Finally, let's discuss plugins. Plugins work similarly to dependencies, but serve a different purpose. Plugin adds functionality to the build system like Gradle and helps automate tasks such as compiling code, packaging apps, or managing versions that, whereas a dependency is a library or external code your app relies on to perform specific tasks. So let me add the required dependency. To save the time, I will quickly copy-paste the dependency required for the data module. You can directly copy these from the GitHub link, which will be mentioned in the description below. But just to give a gist, our data module is mainly responsible for fetching us the data. So we will need retrofit Kotlin serialization, some logging intercepts so that we can see our request and response in the logs, some serialization converter, and HILT for dependency injection. We also need to add few plugins, so let's add them to the version file. After that, we need to first open the root level build.gradle file and add the plugins. Once you set up that, head over to data module build.gradle file and complete the setup for the dependencies. Data module will have the dependency of our code and domain module as well. Once done, sync the project. If you want an exclusive video about dependency injection with Dagger, HILT, and Coin, comment down below and we will bring it up soon. Now let's create the DTO classes, also known as data transfer objects, or in simple words, they are data classes in Kotlin. We will use DTO as the postfix for the file name to make it easily distinguishable. We will use a quick Android Studio plugin JSON to Kotlin plugin. You can search for a plugin in Android Studio settings. Once you install the plugin, continue to the next steps. I already have it pre-installed, so let's continue. Let's go to our endpoint email list and check our JSON response. We will copy the JSON object and with the help of the plugin create our data classes. We will select the advanced option and use Kotlin serialization for the data classes. And we will name the file as email list item DTO. Similarly, we will do it with our email detail response and create the DTOs respectively. Let's also adjust a few fields and double verify if everything is set up as per our need. Now we will create a network module object class inside the DI package. We will annotate this class with a module. This behave as binding instructions, telling HILT how to provide instances of certain types. We will also add install an annotation and pass component class. It essentially defines the scope and life cycle of the provided dependencies. There are various components, and for this we have use singleton component. First, we will add our base URL and annotate this with that provides. This tells HILT how to create an instance of a specific type. It's typically applied to a function that returns an object. After which, let's create our logging interceptor and the retrofit instance. Retrofit instance is created using a builder pattern. We need to pass our base URL, the JSON converter factory, and client. You can use a different version of OKHTTP client if you want. We have used the default one. And finally, let's add our API service interface, which will hold our endpoints and expected response type from the API. For the time, it's an empty interface. Before we jump to the next part where we write our generic way to call the API, let's focus on the core module. Here we will create a package named functional. Inside this package, we will create a file named either. Now, if you prefer, you can include a dependency for a popular Kotlin library called Arrow, which provides a robust implementation of functional programming tools like either. However, for this project, we just need a very basic version, so we'll create our own custom class for either. But what's the difference between either and result, and why have we not used result from the Kotlin library by default? Either represents two possible outcomes: a success, typically called right, or a failure, typically called left. Imagine you're fetching user information from a database. If successful, you can return the user data. If there's a database exception, you can return the error. Either allows more expressive and composable error handling, promoting cleaner code by making it explicit that two possible outcomes are expected and handled. Result is specifically designed for scenarios where you're handling only success and failure, with built-in support for exceptions. We will also create an extension function, which will help us to get the left and right value in Lambda expression at the calling site. Earlier, we mentioned that either can have more composable error. To see this in action, let's create another class failure in the error package in the core module. It will also be a sealed class. For our app, we defined 3 different types of error: network, server, and unknown error. Using a sealed class lets us manage these different error types in a structured and scalable way, making our error handling cleaner and more expressive. Let's jump back to our data module, and inside the remote package, let's create another package and name it as handler. Inside this, we will create a file and name it as network handler. This will have our generic implementation for making network calls. Let me paste the implementation, and I will then explain the code. The gist of the code is that it execute API calls, map successful or failed responses. The safe API call is a suspend function. It takes 3 parameters. 1. IO dispatcher, which specifies the thread for executing the API call. By default, we use dispatchers.io. This is optimized for network operations. 2. API call, a suspend function representing the API request. 3. Mapper, which maps the API response of type T to our desired data model, R. Then we have run catching block. This block safely executes the code inside, catching any exceptions that may occur during the API call. If the response is successful, it checks if the body of the response is valid. If true, it uses the mapper to convert the response body from T to R and wraps it in right side of either. If the response body is null, it returns a failure.server error with the response code and message wrapped in left side of either. If the response is unsuccessful, it also returns a failure.server error with the same structure. If an exception is thrown during the API call, like a network failure, this catches it and calls it .to either, which converts the exception into an appropriate failure on the left side of either. Don't worry about the errors, we're going to resolve them now. First, let's fix the result mapper error. We'll create an interface in our core module under the mapper package. This interface will have a single function, map, which takes an input, T, and returns a transformed output, R. This helps in converting API responses to our desired data models. Next, let's resolve the to-either error. For this, we'll create a file called error handler inside the handler package. In this file, we'll add an extension function for the throwable class that will convert exceptions into our either result type, specifically returning a failure based on the type of error encountered. Before implementing the repository and mapper for the domain layer, we need to create our domain models. The repository interface will also be in the domain layer, while its implementation will be in the data layer. This design keeps our system loosely coupled, allowing us to change the data logic without affecting the core business logic. So let's get started. As mentioned earlier, the domain layer should be unaware of any frameworks, and this is reflected in the minimal dependencies in our build.gradle file. We only need the core module to access either and failure classes, and HILT to inject the repository interfaces. After syncing the project, let's create our model classes. Head over to the model package inside the domain module and create 2 subpackages, email details and email list. In the email list package, we'll create a data class named email list item model. This is separate from the DTO because, as mentioned earlier, the domain layer should not depend on other layers, especially the data or presentation layers. Next, we'll do the same for the email details package. Additionally, we'll create 3 more data classes, file info, recipient, and sender info for better clarity. You can combine them if you like, but I prefer separate models for better organization. We'll now create the interface for the repository and name it email repository. Inside this interface, we'll add 2 suspend functions, getEmailList and getEmailDetails. These functions will return either a failure or a successful mapped domain model object using the either type. Next, head over to the data module, and in the repository package, create an implementation class for email repository. We'll override the methods and fill in the implementations for these functions. Now, our goal is to make API calls, but we haven't completed the API service class yet. So let's add two endpoints, getEmailList and getEmailDetails, using the @get annotation and specifying the endpoints. The return type will be a retrofit response class of ArrayList. Additionally, you can explore other HTTP operations like post, put, patch, and delete. Now that we have our safe API implementation, we need to map the DTO to domain classes. Let's start by creating our email list mapper inside the mapper package. First, we'll implement the result mapper interface and define the input as a list of email list item DTO and the output as a list of email list item model. Next, let's override the map function. For error handling, we'll filter out any data where the ID is missing or the sender info is null. Once the list is filtered, we'll map it to the domain model. You'll notice the use of the double bang operator, which isn't typically recommended, but it's safe here since we've filtered out items with nullable fields like ID or from. If you encounter errors, it's likely because some fields in the domain model are non-optional. To fix this, let's create a couple of handy extension functions. A nullable Boolean extension function that returns false if the value is null. A nullable list extension function that returns an empty list if null or applies a transformation if the list has values. These will help keep the code cleaner and ensure default values are provided where needed, and we'll use these functions soon. Let's quickly add the mapper class to map the list of email details to the email details model. We'll repeat the same steps as before, implement the interface, override the map function, and write the logic to convert the DTO objects into domain model objects. Here is the complete implementation of the class. You can pause the video and review it. We've created two helper extension functions, one for sender info and one for the list of recipient info. While optional, this approach encourages better coding practices. As homework, you could try doing the same for the file info implementation. In the toRecipient model extension function, we used our list extension function, which returns an empty list if null. Otherwise, it maps the list to recipient model and returns it. Now that our mappers are ready, we can continue with the repository implementation. First, let's inject our API service class and the two mapper classes email list mapper and email details mapper that we just created. Next, we'll write the implementation for the suspend functions getEmailList, starting with calling our safe API call method, which takes two Lambda functions, the API call and the mapper. For API, we will call apiservice.getEmailList, and for mapper, we will call the map function of the email list mapper. Similarly, we'll implement the logic for the second method. At this point, we have most of the pieces in place, but two things remain. First, we need to inform Hilt how to create an instance of the repository implementation. And second, we need to create our use cases, which will be called by the view models. Let's create the repository module as an abstract class inside our DI package. We'll annotate this class with that module and tell Hilt to install it as a singleton component for the project. Inside the class, we'll create an abstract function bindEmailRepository, which tells Hilt how to create the instance. Annotate this method with @binds. Next, let's quickly create our use cases. The first one is getEmails use case, where we'll inject the repository and create a suspend function that calls the repository method. Then, we'll create another one, getEmailDetails use case, following the same steps. One last thing before we end the video. Let's quickly check if we're able to hit the API call and confirm that our mapper functions are working as expected. For this, we'll create a fun main method and write the block of code. Since our methods are suspend functions, we can call them only from another suspend function or a coroutine. To handle this, we'll wrap the code with run blocking. We'll also create a quick mock API service class to mimic our server. Once we run the code, we can check logcat to see if we received the email list result with the successful result on the right side of either, and validate that the from value is coroutine lab. Similarly, We'll check that email details result has the correct model values for the sender info model. This code is only for testing, so you can delete it once everything is working as expected. Stay tuned for the next video, which will be dropping soon, where we'll cover the presentation layer of our Gmail mock app. Thanks for watching. Don't forget to subscribe to our channel and like this video. Also, hit the notification icon to stay updated on our upcoming videos.